Tonight we are working on this 2015 Acura TLX, and it was brought to me by another shop. It was towed over, and the customer's complaint is that it will not engage any gear. It won't go out of park into drive or reverse or neutral. This is it's not your conventional shifter. It is an automatic transmission, but it has I don't know if you call it an E-shift, where basically it just has buttons for the driver to request gears. Once you hit any of the other gears outside of park, it'll flash and just stay in park. And for me, this is going to be my first time diagnosing one of these transmission shifter systems. So let me get you a shot of the trouble codes first foremost and kind of try to decide what kind of direction we're going to take. Okay, so I'm going to start scanning it and at the same time get you a shot of what it does. So we'll key it up, and it is in park, and it will start. Well, I've got the intake off now. It'll start running idle. Let's see. Well, can't keep it running, but let's say I want to go neutral. So that's all that it'll do. So yes, I know it's stalling, but if it were to stay idling, that's basically what it does. It'll light up via the request that you're asking for, giving it, but then it'll jump back and light up the park button. Okay, and so these are the codes that it currently has. And yes, I scanned it the other day when it came in. And the two main ones that I'm concerned with, or at least for the moment, these two that come back right away, and that's the 0980 and the 07E6 stuck in park, and then shift solenoid valve C high input. So these actually would go away, but these two are the hard ones. So let me see if I can make that happen. Back out, we'll see if we can erase them. Yes. Okay. Turning off, and we'll turn back on. We'll reread. Okay, these are popping up because I've got the mass airflow unplugged, but not anything to do with transmission. So right now that we've cleared it and not attempted to actuate gear engagement command, nothing is seen as gone wrong, basically. So let's see if even in car off or anything, if we request neutral, not sure if it'll work. Let's reread. Okay, still not. So let's see. Okay, so okay, there we go. So again, the 0980, the valve C high input is the one that always returns, and then that stuck in park. But again, you can't get it to see that something's faulty if you're not attempting to request gear change with the car on. So these are the ones I'm going to attack and try to see if we can figure out and get this whole situation working. So now just quickly, I wanted to browse in live data. I'm bringing up this data PID. I don't know 100% what I'm supposed to be looking at or for, and even if these are the correct PIDs. All I'm seeing is a solenoid valve C, and then you've got A, B, D, E, and a pressure control one. Right now, key on, engine off, they're all 50 milliamps, whatnot. I want you to obviously pay attention to C. We'll try this. I'm hitting neutral. So there is, what I'm gonna hypothesize is that there is an attempt of control for that solenoid, because we clearly see the values change to a higher numerical value along with some other ones. But this is just trying to get some sort of an idea of plan of attack, because what the system is comprised of, and I'll get you a shot of all that here. And just for the information wise, there is no active test menu that I can go to try to get the solenoids clicking to try to see if there is any activation that we can audibly hear. So there is no active test menu. As far as what the system is, first and foremost, it is a ZF. There you go. It's a ZF front-wheel drive 9-speed transmission, and I believe the code for this one in the Honda Acura world, it's a ZF9HP48. And if the pan is there on the front, the module is here on the back. That's the connector for the module, and it kind of runs along the back bottom side of the transmission. And that connector is, there's a like sub harness, runs along to basically a round connector that goes into the pan for the valve body for all the solenoid control. There you go. What I'm dealing with is to try to figure out why we've got the stuck in park and the solenoid C valve trouble code. Now this is it's similar to what I'm more familiar with the ZFs in the BMW world, where it's E shift, and it's got all solenoids that control the functions of the transmission. So I quickly looked at the information, and there's, I think it was 10 solenoids. And at least the good thing about this is the module's outside, not internal. So we can actually run tests to try to differentiate and find out where the problem is. If it's in the module, if it's in the harness, or in the solenoid, or the valve body. So there's different possibilities here, and so my job right now is to make sure everything externally, computer, harness, and signals and all that, is going to be there and proper before digging into the transmission. And quickly wanted to show a generic drawing or diagram of the solenoid system with the TCM based off the trouble code for the valve C high input. And so what they're showing you is that this is the transmission control module. Here is the valve body assembly, and here's a 12 volt battery voltage supply. It goes in, and it's going to feed, at least for what they're showing here, this 1, 2, 3, 4, 5, 6 of them. And here is that, I'm going to assume, solenoid C, since there's A, B, C, D there. So those 3 or so shift solenoids, along with others, are all fed constant 12 volts, and then individually pulsed and controlled by a separate single wire. So that gives me at least an idea of possible ways of testing, knowing that they share a power feed. And to see if I can keep this quick and simple and short, I'm going to try to go not so crazy high tech, and just, if the steps were telling us to check from on the transmission from pin 3 and use 35, whatever. So I came out here, and pin 3 is going to be that 12 volt or the power source going to the solenoids. So like it says, it powers up the actuator, lock actuator, which we are having that trouble code for stuck in park or whatever. But solenoid valves and pressure regulators, just like we saw in that generic diagram. So that's pin 3, which we know based off of this goes to pin 1 here on the transmission. So 3 is the same as 1 here. And 35 from the test plan there is the basically other end of the control side of solenoid C. But on that diagram we saw solenoid B and A. So my quick mindset is going to go to ohm testing, and I'm going to compare basically from pin 3 to 35, then to 36, then to 38, because we know we don't have codes for B or A. Compare those two and see what they look like compared to C. So that's what I've got here. I've got the battery out the way, this unplugged, and the face of the valve body connector is there now. Luckily, and I was kind of surprised. Again, I'm used to dealing with the ZF and a lot of other Europeans and stuff, but the harness is not labeled. Normally on BMWs, the face would be labeled with numbers, and no, that's not corresponding to actual number 2. And even if they're not labeled here, they would be labeled here. And so I was surprised to see no numbering. But yeah, I do have that diagram from the Honda that I printed out, Honda service information, and I believe it's describing on the face of this as far as pin numbers. But in ZF fashion, they did put the numbers there on the connector of their transmission. So I'm not knocking Honda. It's one of my favorite car lines, but I was just surprised to not see numbering here. But nonetheless, we can go ahead and then use that numbering system, and we'll do ohm checking for all 3 solenoids and see what we get. And in order to try to break down to find out the pins for solenoid B and A, I'm using this so we know at the transmission, pin 11 is going to be basically the same as 35. So that is solenoid C, the control side. So 11 essentially is 35 on this. And so I found this diagram, and here at the bottom is the transmission control module, and there's 35, and that should go to pin 11, which it does. So this here is the what they call, hydraulic sensor unit or something, but basically this is that valve body connector, and it's showing solenoid connections. And being that I can now figure out the numbering on the actual transmission round connector, I can go and use the transmission numbering to find out what number on the valve body. So for instance, let's see the next one. So 36, since I don't know where 36 goes to this round one, I'll just simply look for 36 here, which is right there. and I'll follow that up. And that gives me number 8. And I'll do the same for the other one. So that is how I'll get my pin numbers at the valve body to do the ohm testing. Okay, so I realize I'm getting a little bit ahead of myself. Some of you guys might say, as to why I'm starting down there and not, powers, grounds, even the harness to the solenoids. And it's only because of just gut feeling of thinking it's going to be something solenoid related. Why? Just, again, gut feeling. The other thing is because we know we have a shared power source for many other solenoids, and right now it appears that 2 are only having issues creating trouble codes, and all the other ones are still supposedly okay. So part of that is why it's kind of making me think it's going to be in there. So that's why I'm thinking of starting to test solenoid ohms from out here. But just to backtrack a little to show you, based off of, because of the trouble code, that it was supposedly a high circuit, I will show you ohm testing from here to the transmission computer connector. And I know you're supposed to load test it, and maybe I will on camera show you, but right now just quickly do an ohm test to show you. So I am in the control line for solenoid C, and I'll tap into, and I've got it set to make noise for continuity. Okay, so we are looking for pin 35, and then you see 33 there, and so going towards the left, 33 is empty, 34, 35. So that is where I'm at. So again, I know you're supposed to load test it, but just a quick reference, there is a connection from there to here before I go ahead and ohm test that, so I know the supposed open is not there. At least right now. Yes, I know only one strand could be tying everything together as far as ohm checking. Again, if I have to load test it, I'll load test it. Right now I'll move forward and check ohms on the solenoids. And so this one's going to be our feed, or our constant. So I'll get this one here, and I'll switch this to regular. Okay. Number 2, which is next to it, is I think one of the other solenoids, so we'll get in there. We have 64. Okay, this one is on solenoid C control, and way different reading. And lastly, I'll do the third solenoid. So we did from pin 1 to pin 2, so it's solenoid A, and then we checked from 1 to 11, which was C, and then so we'll check number 8 and 1 and see what solenoid B gets us. And I am in number 8, and 8 actually gives us a third different measurement number, so I wasn't expecting that. Okay, so just being that I've got 3 different ohm readings, I decided to go to another kind of quick crude test, and that is to simply just apply a quick 12 volt to each of those solenoids and see if I can hear something. And I also, at this point now, am overcomplicating it because I am adding the scope and the measurements that I am going to take and capture. A lot of it is more to get you guys a visualization. I was going to do the amperage of the solenoids when I apply voltage to it through the jump box, but then I decided to also tie in voltage because why not? So that way I can visually get you guys to see. I'll try to place the camera to where hopefully it'll pick up noise if we get noise. So for the first test, I'm going to do what's a known good, supposedly. So it's going to be pins 1 and 2. So 1 and 2. So we are testing solenoid A. Okay, I did 3 taps. And I'll stop the scope. So red is going to be my amp clamp, and there is the 3 vents, and there is a good picture there. Okay, so that is one of our known goods. And now we'll switch over to number 8, which is solenoid B. Hopefully you pick that up. Again, there's our 3 vents in pretty much similar waveform. Okay, so about 1.26 amps on that one. So now I will go to, actually I'm going to test that first one to get the amperage. Amperage reading of the first one, which is pretty much the same place despite the different ohm readings. And so now we'll go to solenoid C. Okay, and I'll put you down here again. Okay, so I did multiple ones, nothing audibly heard, okay, so we've got something here. I'm glad I took both amp and voltage. So the dotted lines are still from the previous 2 solenoids, and for amperage difference, there we go. It's almost 4.5 amp difference, and this one goes all the way up to 5.5, and it looks like it is shorted. So there's no small hump here, which a good working non-shorted solenoid will have that small buildup there in the beginning. If it shoots straight up like this one definitely is, it is a shorted solenoid, which this one did have the lowest on the at least on the meter as far as ohm reading, and we are definitely getting a shorted solenoid waveform.